Yeah, welcome to my video blog Questions of Doubt in Corporate Valuation. My name is Bernhard Schwetzler, and our today's question of doubt is there a general, more flexible debt policy than the Modigliani-Miller or the Miles-Etzel policy? And the answer is, of course, yes, there is. Otherwise, I would not have produced this video. Okay, so a short recap on these two debt policies. They are standard policies that are used in order to quantify the benefits, the tax savings benefits that are related to the tax deductibility of interest. So the Modigliani-Miller debt policy assumes that the level of debt is constant and maintained independently from the development of the firm value. And then you get this well-known equation for the tax shield, whereas the Miles-Etzel debt policy assumes that the leverage ratio of the firm is kept constant, and that yields this equation for the value of the tax shield. Yeah? So you either can fix the leverage ratio or you can fix the debt level. Yeah? And these are the only two options that are at hand. And the problem is, of course, A, they yield different tax shield values, and by doing so, of course, also different firm values. And B, nobody knows the correct or the appropriate assumption for these debt policies. And what I would like to show you right now is that there is a more general debt policy, and the Modigliani-Miller and the Miles-Etzel debt policy are polar special cases of this. Yeah? And this can be best highlighted by first looking here at the Miles-Etzel debt policy, where the leverage ratio is fixed. So you see here, this is our firm value 100 and 0, and we have a leverage ratio of 50%. And the idea then of this Miles-Etzel debt policy is that after 1 year, for this 1 year, the debt level stays constant. And after this 1 year, then again, the absolute debt level is adjusted by multiplying our leverage ratio with the then prevailing firm value. Yeah. So and then this debt level is again kept constant for 1 year, and then if the firm value goes up again by X%, then the debt level is also going up by X% because the constant leverage ratio is multiplied with the then prevailing firm value. Yeah? So and the idea is then that every year the debt level is adjusted towards the then prevailing firm value. Yeah, this is the basic idea of the Miles-Etzel debt policy, and that's the reason why you discount the tax savings over one period just with RD, because for this time the debt level is certain, and then after 1 year it is adjusted towards the then prevailing firm value, and that yields then that all other tax savings that are beyond the next year have to be discounted by the risk-adjusted cost of unlevered equity of the firm. Yeah? So you see that the ME policy implies that every year after 1 year the debt level will be adjusted. Whereas here on the opposite side you see that the Modigliani-Miller debt policy assumes also that we have a debt level of 50, but you see also it assumes that the debt level is never adjusted no matter where the firm value is going to go. Yeah? So of course the firm value is a random variable, but you see here that the debt level is maintained no matter where the firm value is going to go, and that means that this is a special case where the debt is never adjusted. Yeah? So, and these are two special cases if you look at it of a more general debt policy. And the more general debt policy is simply that you say after K periods, I adjust the level of debt towards the then prevailing firm value by multiplying it with my target leverage ratio. Eh? So here, this is then the special case of this adjustment happening every year. So K, which is the sequence of adjustment, is then equal to 1, whereas here it is never adjusted, and so this is then the special case where K, that is the sequence of this adjustment, is going to go to infinity. Yeah? So in that sense, the basic and more general idea is that you say after k periods, so I will adjust the level of debt towards the then prevailing firm value by multiplying the then prevailing firm value with my leverage ratio. Yeah? So here you see, for instance, K may be 2 or 3 or 4 years, and you can choose K freely, and that means that this more general policy gives you additional discretion when trying to find the optimal debt policy in corporate valuation. Yeah? So, and the basic idea for the valuation of the tax shield is then that you say over these K periods where the debt level is kept constant, the tax savings, the annual tax savings attached to the tax deductibility of interest is to be discounted with RD. So that means that for every sequence here starting in 0, starting in K, starting in 2K, you always have the present value of these sequence of the tax savings. And then for the later present value of tax savings, you discount them down to 0 by applying the unlevered cost of equity as discount factors. Yeah, because then after K, the risk of this additional present value of tax savings is equal to the risk of the development of the value of the firm. Yeah, so that would be the basic idea. Yeah, and you see that obviously if we set K equal to 1, then it exactly is equal to the idea of the Miles-Etzel calculation, where for one period you discount with RD, and then for all other periods you discount with the unlevered cost of equity. So we can further simplify this equation here in 3 steps. So as I said, the first step is that you always discount the annual tax savings here, the expected level of the debt times the tax rate, the corporate tax rate, times our cost of debt. This is the expected tax savings, and as this is an annuity, you can calculate the present value of this annuity over K periods by dividing it with the annuity factor with RD and K. So you see that this is the first step. This is always the present value of K periods tax savings calculated based on a discounted of RD. And now the second step of the simplified valuation procedure is that we convert this present value at the beginning of 0, K, 2K, and 3K, that we turn this present value again into an annuity by multiplying it with the annuity factor, but now with the unlevered cost of equity. Yeah. So, and that means that we have again an annuity from 0 to K, from K to 2K, from 2K to 3K. But now if you take a closer look, then you see that this sequence of annuities is then simply a perpetuity, and that allows us in the third step to calculate the total present value simplified by dividing this sequence here, or this perpetuity, by the unlevered cost of equity. Yeah? So this is then the equation for our tax shield with a sequence of K period where our debt level will always be adjusted to the then prevailing firm value. So this is the general equation for our perpetuity. Yeah, so we assume that the leverage ratio is constant, and that means that the expected value of our debt level is equal to L times the expected value of our firm value. And in the perpetuity case, the expected value of our firm value for all future periods is equal to the current firm value. And that means that we may replace these expected values of the future debt levels by the current debt level. Yeah? So, and this is the general equation here, that we have the value of our tax shield is the current debt level times this factor here, lambda KT. And you see that this lambda KT is the factor that we have just been deriving here in our 3-step procedure. Yeah? So, and now I'd like to show you that all standard debt policies that are currently cited in the literature are special cases of this equation. Yeah? So you see here, the first thing is we look at the Modigliani-Miller policy. That means the debt level will be never adjusted towards the future firm values. And that means that our adjustment sequence K is converging against infinity. And that means that the annuity factor for this case is then converging against the discount rate R. And if we replace the annuity factors here in this equation, here by RU tau and by RD, then you see that it cancels out and lambda is equal to tau. Yeah, that is the corporate tax rate. And that's exactly our Modigliani-Miller policy. So if we look at the Miles-Etzel policy, then this is a special case where the debt level will be adjusted every year towards the future firm values. That means this is the special case of K being equal to 1. And that means that the annuity factor is then turning into 1 plus R. That yields this lambda factor, and this is exactly equal to our Miles-Etzel tax shield equation. And finally, there is a third policy that is known or well known in corporate valuation. This is the so-called Harris-Pringle policy, where our tax shield is simply calculated by discounting the annual tax savings right away with the unlevered cost of equity to get the present value. And this may be interpreted as an immediate adjustment or an instantly adjustment of the debt level towards the development of the future firm values. That means that K is converging against 0, and that means that this annuity factor is then converging towards 1, and if it converges towards 1, then this is the equation for lambda, and this is then the equation that we get for the tax shield, which is equal to the well-known Harris-Pringle policy. Yeah? So all three are then special cases of our more general policy, picking or choosing an appropriate adjustment sequence of K. So the nice thing about this more general debt policy is also that it provides, under certain simplified assumptions, also a nice link towards the counter effect of debt, the dark side of debt, that is the default probability and the expected bankruptcy costs. Yeah? Because it is obvious that K is also driving the default probability. Yeah? So you see here that, for instance, if we look at an Modigliani-Miller debt policy where the current debt level is supposed to be maintained independently from the future firm value development to infinity, then you see that obviously the fact that D is never adjusted yields an increase in the default probability over time if we agree that the future firm value is a random variable. Yeah? So we say then that the default probability is simply the probability over a certain sequence of K periods until the next adjustment, where the firm value will drop below this face value of debt. Yeah? Whereas if you look here, for instance, for the special case of K equal to 1, for our Miles-Etzel debt policy, that as our debt level is adjusted every year towards the then prevailing firm value, then of course you see this shaded area here, the probability that our firm value will drop below the face value of debt is then significantly lower. Yeah? So that means that there is a straightforward link between the probability of default and our choice of K. Yeah? So the higher K is, the higher the probability of bankruptcy, looking at this particular trigger here, becomes. Yeah? And that allows us to put the two things together, yeah? Because of course our choice of K also affects our tax shield value. So to wrap up, our general definition that we have seen here of a debt policy affects both the bright side of debt, that is the tax shield value, and the dark side of debt, that is the expected bankruptcy costs. Yeah? So, and our general definition of a debt policy is now a combination of a certain leverage ratio, L, in percent of the firm value, and the time to maturity, which is of course here measured by the length of this refinancing sequence, that is K periods until the debt level is adjusted for the next time. Yeah. So if we start with a given target leverage ratio, then this simply assumes that after K periods, the debt level is renegotiated and is adjusted towards the then prevailing firm value by multiplying the then prevailing firm value with L%. Yeah? So the leverage ratio and the time to maturity as the two components of our debt policy has an impact on the value of the debt-related tax savings, that is the tax shields. On the other hand, these two components of our debt policy also have an impact on the default probability, and by doing so, of course, on the expected bankruptcy costs. And that means that this debt policy sets the frame that would allow us to pick the optimal debt policy according to the trade-off theory out of corporate finance, that is balancing the bright side, the tax shield value, against the dark side, the bankruptcy costs. That's it for today. Thank you.